To this computer. Okay, all right. So welcome everybody. Thank you all for being on time today. It's good to see everybody after 3 weeks. I hope you all had a good unification day and a couple weeks, and that everybody's well, and that your families are all well. Um, so we only have two more sessions, so just this week and then next week is the last session. And so I want to do something a little bit different with today. I'm going to talk about a piece of technology that can be useful for typing mathematics. But in the meantime, also just a reminder to type in your name so that I have a record for your attendance, so that we can make sure that you get your data for next week, which will be the last week. Yeah, so I kind of want to get right into it with the technology, and then next week we'll do a little summation and discuss the next steps and certification and everything like that. Okay, so welcome again. Thank you for coming, and let's get started. Okay, so the technology that I want to talk about is a way of typing math. How do I type math for my slides? How do they type up the problems for the WMC? And usually, what you find is if you try to type math using your phone or using a keyboard, that this can get very frustrating, right? If you want to do any kind of complicated mathematics expression, it can be very difficult to type it up, or you have to use these keyboard shortcuts that don't necessarily look so good. So, typing math without any special tool can be a fairly difficult thing to do. And this is, of course, because math has letters and numbers and maybe some basic symbols that are easy to find on a keyboard, but it's got all sorts of other symbols, integral signs and angle signs. So there's tons of symbols that are not on a standard keyboard. And then on top of that, there's subscripts and superscripts and equations and fractions and other things that are just not that easy to type without using something that looks kind of ugly, just using a bunch of keys. Okay. So the best way to type mathematics, which has been, universally embraced, I'll say, by the mathematical community, but also computer science and also physics and also, anybody who does science at a high level, is basically using a program called LaTeX to type mathematics. And so this is pronounced, it's not pronounced latex like the rubber, it's pronounced LaTeX. That's how you pronounce it. For whatever reason, the X here is pronounced like a K. So call it LaTeX. And so, what I want to do today is give a little introduction to how to use this program. It's actually a lot of fun once you get over the initial hump of how to do it. And I'm just going to scratch the surface, but I'm going to give you a bunch of resources if you want to learn more about how to use this LaTeX. If you want to learn more about how to do it, there are a lot of resources free resources that you can follow. And I should mention that LaTeX is the program that I use to create the slides for this workshop, right? So I'm not going to talk about slides specifically today, but I think I will, maybe if there's a little time next week, I'll talk about how I make slides, in case this is something that you ever want to do for a workshop that you're running. Okay. So this is the program for today. And so I want to say, why typeset mathematics? I mean, of course, you can write things out by hand, and often that's fine. But correctly typeset mathematics, first of all, it looks really good. There's something beautiful about seeing, mathematics nicely typeset on the page. It's very, very readable, and you can use it if you want for exams or handouts or, any presentation slides, like the ones I'm doing now. Okay. So, and whatever reason you might want to type up some piece of math, and also in general, anything mathematical typed in LaTeX, and it's always written this way with the L, the T, and the X capitalized. It's just some marketing thing. So anything mathematical typed in LaTeX will look more professional. And it's not only for math. I use LaTeX to write my resume. I use it to type everything now. I never use a word processor. The only thing I ever use is LaTeX. I use it for letters of recommendation. I use it for my resume. I use it for everything. But today I'm going to teach a little bit about how to use it specifically for mathematics. Okay, because that is the subject of our group. Okay, so it looks like a few more people have come in. I just want to welcome them before I start with anything technical. Um, okay, so Emmanuel just came in, and Abraham just came in, and Alexander. Just want to welcome everybody. Just recall that LaTeX, yes, it's an app that's used for mathematical expression. But it's not really an app in the sense that I don't think you download LaTeX itself for your phone. There are different versions of LaTeX. I'm going to talk about LaTeX is basically a language. You should think of it as a programming language, kind of like HTML. Um, so, sorry, sorry. So you should think of LaTeX as being akin to like HTML. So HTML is what you type in order to make a website, and LaTeX is what you type in order to make math. And I'm going to show a program that lets you use LaTeX today, which is called Overleaf, which is the easiest way to get into it. Okay. And we're going to do a lot of examples today. We're going to go behind the scenes and see, how everything looks when we type this. Um, by the way, I guess I should also mention, I forgot to say, so since the last time we met, the WMC happened. I saw pictures from both the Monrovia and the Ganta competitions. Everything looked like it ran pretty smoothly. So I want to thank everybody who was involved in the organization. So here I think that's Abraham and Alexander and Deborah. And then I also want to thank anybody who coached a team for the WMC. So I think we should hopefully get the results pretty soon, but it seems like it went fine. And I just want to thank everybody whose efforts were important for getting the competition to happen. So thanks to everybody who worked with the teams. Okay. Um, Good. I want to say that now that there's more people here. Um, okay, great. So back to LaTeX. It's really a way to make what you're writing look professional. Okay, and it looks much more professional than using Microsoft Word or using, just like Notepad or something like that. Okay, so the drawback with LaTeX is that it can take a little bit of time to get used to. That's why we're doing a workshop for this. So the easiest way to jump in is to use a web-based program, which is called Overleaf. Okay, so Overleaf, of course, has one big drawback, which is that you need to have an internet connection to use Overleaf. It's free, but you need to be connected to the internet. If you have access to a computer with no internet connection, then you can also use LaTeX on that computer. But this requires downloading some programs and doing some setups, and this can differ based on your operating system, based on whether you're using a Mac or a PC or Linux, or that there's all sorts of different setups as opposed to Overleaf on the web, which is uniform for everybody. So I don't think it's useful for me to go through setting up LaTeX on your computer offline today because for the people who have access to a computer, every system is going to be different. But if you're interested in setting up LaTeX on a private computer so that you can use it even when there's no internet connection, that's something that I can help you do privately if you want. So reach out to me afterward and I can help you set it up. Everything is free. It's just setting it up on a computer can be a little bit annoying, whereas using Overleaf is much easier. Okay. And I guess the last thing I should say is nowadays, to some extent, maybe you don't really need to learn LaTeX because an AI system can just write the LaTeX for you. You can just say, write out a nicely math typeset, type the following stuff up in LaTeX, and you can just like describe in words what you want it to type, and it'll probably just do it pretty well. So maybe I'll talk a little bit more about artificial intelligence and how this interacts. I'll talk about this next week. But for today, we're going to work the old-fashioned way. We're going to do the code ourselves, work with everything from the beginning. Okay, so although rapidly the landscape is changing in terms of how much you need to know to write LaTeX, it may be that pretty soon AI will be able to do most of it for you. Okay. All right. So how do we get started with this overleaf? So I'm going to demonstrate everything for you. So the first place to go is this website, www.overleaf.com. So if you go to www.overleaf.com, you'll be prompted to create an account. So let me share what happens. Let me share what happens here. Okay, so if I go here, so if I go, let's say I'm going to make a website here. Okay, so I'm going to type in www.overleaf.com. Okay. And if you go to www. Oh, well, so I'm already logged in. So let me log out so that let me log out so I get the regular screen. Okay. Okay. So if you go to www.overleaf.com, you get this screen over here. And can everybody see my screen? Is that okay? Okay. So if you go to
It's okay,
Overleaf.
that.
I think it's better. It's
It's
better,
good.
yes.
It's good. Good.
It's okay.
So,
Yes.
so you'll get this screen, and over here, if you want to sign up for your own Overleaf account, you just have this box where you can write down an email address. So you need an email address, and then you can make a password, which can be whatever you want. And then you click on sign up for free, and you'll automatically get signed up. Okay? So I already have an account, so I'm going to log in. I'm going to go up here to log in instead of sign up. So I'm going to log in here as my email address, which over here, andrew@gmail.com, and my password, and I'm going to go log in. And so when I log in, don't worry about everything that shows up on this screen. These are all just different accounts and different papers that I have. But when you log in for the first time, you're going to get some screen that sort of looks like this. So let me go back to my Zoom. Hold on. How do I want to do this? Yeah, so let me go back to my Zoom. Um, so where are we here in the meeting? Okay, so I want to go back and share here. Okay. So let me. So everybody, if you have maybe I'm gonna go. Yeah, so let me say, so once you have an account, then so does everybody, by the way, on Zoom, do you have tabs? You should have two different tabs to look at. One tab is going to be this Overleaf screen over here, and then there should be another tab that has my slides on it. So are you able to navigate to the screen where you're just back to my regular slides here inside your Zoom? There should be two different tabs that I have open. So can everybody see just my regular slides at this point, or
Yeah.
Yeah. For me, I can see it, but not
Yeah,
just clear.
okay?
yeah.
Yes,
I
Uh,
I
can
can
see it.
see it.
Most.
okay. Well, for most of what we're going to do this is the last slide I'm going to do, and then I'm going to be going back to the computer screen. So once you have an account, then you can get started at this website. So it's called docs.overleaf.com/getting started/LaTeX tutorials. Okay, and I'll show this all to you on the website next. But what you're going to see there is a document there that's called Learn LaTeX in 30 Minutes. I think this is a little bit over optimistic. I think it will take more than 30 minutes to go through that document, but it's a nice introduction, but it is big enough that it will take more than 30 minutes, and it has a lot of text. So it's nice for reading and going through on your own, but I don't think it's the best thing to present today in a visual method to everybody. Sorry, question?
Yeah, Doc.
Yes, Emmanuel.
I mess up a little bit on what you were saying about the website instead of you
So
said
when
typing www. Can you connect me? I try to practice that with the computer on.
Okay, well, so if you go to www.overleaf.com, you can make your own account. You need an email address and a password. And so you put that in, and then you can make your own account. Um,
Okay.
okay, and then you have to
The
just follow
overlay is there.
yeah, so it will give you
LEAF.
instructions. Hmm.
Are you there? Is
Yeah,
it
I'm here.
LEAF?
Yeah, Overleaf.
Yeah, yeah, okay.
Yeah,
Yeah,
overleaf.com.
okay, thank you.
Yeah. And then you'll make an account and it says email address and password. So you put that in, then you can follow directions and make an account. Okay. So for today's and again, if anybody needs some help with this after class, I can walk you through it on WhatsApp. Probably I won't have that much time directly after class today, but I can walk you through it another day whenever you want. Um, but what we're going to do today is we're going to do this tutorial here at this LaTeX tutorials. So I'm going to go to this, once I go through this slide, I'm going to go to this website. So as I mentioned, there's this first document there called Learn LaTeX in 30 minutes. That's going to take you more than 30 minutes. It's not what we're going to do today. But there's a second tutorial there, which is called Dr. John Lees Miller's three-part LaTeX tutorial series. And this is nice because it's formatted using slides. So it's a nice visual presentation. And our goal for today is to go through part one of this presentation together in its entirety. And if you like it and you're interested, then you go through parts two and part three on your own. Okay? So what I'm going to do is go now to this website over here with the LaTeX tutorials, and I'm going to share my screen. Okay? So I'm going to share my screen over here. So everybody, if you can navigate to the other tab where I'm sharing my screen, I'm going to type in that address over here. So that's docs.overleaf.com, getting started LaTeX tutorials. So I'm going to press enter there. And in fact, you may not need an account to start this. You may be able to just get started here. So here on this website, they have all sorts of resources to help you learn this. So Overleaf LaTeX tutorials. So there's also videos, but I'm going to do the self-guided tutorials for now. So Overleaf LaTeX tutorials, you just slide down to this. So this is the first one that I was talking about here, Learn LaTeX in 30 minutes. So this is an introductory tutorial, but I think it will take longer than 30 minutes and it's not the best for a visual presentation. So I'm not going to do this one now, but if you have time, I encourage you to do this one on your own. Okay. Um, so instead, I want to do this. I want to look at this Dr. John Lees Miller's three-part LaTeX tutorial series. Okay, so he's one of the founders and he wrote a three-part tutorial to get new users started. Okay, so the three parts here, we have part one, which is the basics. Part two, structured documents and more. This is about writing things with chapters and theorems and sections. And then part three, not just papers, presentations, and more. This is about doing slides, the way that I do slides for our workshop. Okay, so these other two, again, may be something that you're interested in doing on your own, but for today, the goal is just going to be to walk through part one, the basics, and then do a couple of exercises on this. So I just want to make sure, can everybody see my LaTeX screen over here with the basics?
Yeah, yeah.
Okay, everybody's okay? Good. Okay, so I'm going to click on
It's
this.
okay.
Good. Okay, so I'm going to click on this part one, the basics. And you get this free online introduction to LaTeX, part one. So we'll just read this over here. Welcome to the first part of the free online course to help you learn LaTeX. If you've never used it before, this is the place to start. It will get you writing LaTeX right away with interactive exercises that can be completed online, so you don't have to download and install LaTeX on your own computer. And in this part of the course, we'll take you through the basics of how LaTeX works, explain how to get started, and go through lots of examples. Core LaTeX concepts are introduced as they arise, and in particular, we'll cover setting up a LaTeX document, typesetting text, handling LaTeX errors, typesetting equations, and using LaTeX packages. So this is,
Tarosa,
yes, question.
Tarosa,
Yeah, Rush?
Ghana getting you breaking in a little bit.
Okay, sorry.
Yep.
I'll
Yeah,
try to
man, the
speak closer
network.
to the microphone.
Not getting you, not getting you.
Not getting me at all?
No, I hearing you, I hearing you now.
Oh, good now. Okay, great. Okay, got some more people coming in. Okay, so these are introduced, and then they talk about parts 2 and 3, which we're not going to go over. And if you like French, the slides have been translated into French. Okay, so you can download a PDF over here, or you can browse the slides below. Let's see, what are the several other languages that it's translated into? Um, so Catalan, Chinese, Spanish, Finnish, Italian, Portuguese, and Russian. Okay, we don't need that. Okay, we will do it in English. Okay, so I'm gonna click on this so you can browse through the slides if you want to over here, but instead I'm just gonna click on the PDF and do this like a presentation. Okay, so this is the course. So an interactive introduction to LaTeX. And so part 1, the basics, this is what we're gonna go through today. Okay. So this much I already said, right? So why LaTeX makes beautiful documents, especially mathematics, but not only mathematics. I do all of my word processing in LaTeX now. I don't use any other programs. Created by scientists for scientists. There's lots and lots of people who use it, and it can be extended. So there's extra special packages that you can get that help you do spreadsheets, that help you do presentations, that help you do slides, that help you do books. Anything that you want to write, you can usually find a LaTeX package that will help you write it. Okay. So how does it work? So the way it works is that everything that you type in the document is just written in plain text. It's just written with letters and numbers and punctuation the way you would write anything normal. But then inside your plain text, there are certain commands that tell LaTeX, I want you to make something that looks like this. And then the LaTeX program, what it does is it processes the text that you write and it processes the commands and it then makes a very beautifully formatted document. So for instance, let's say you're writing this sentence. You want to write the rain in Spain falls mainly on the plain. But you want this word mainly to be in italics. Okay? So the way that works in LaTeX is you can't actually put it in italics because LaTeX, all of your input is just written in terms of plain text. So the way that you put a word in italics in LaTeX is with this command. So you write \emph. This stands for emphasis, EMPH. And then whatever you want to put in italics, you put inside curly braces over here. So you want the word mainly here to be in italics, you have to do \emph and then put it in curly brackets, and this is going to give you something that goes that when you compile it and print it out, it's going to look in italics. So in math, this is often what we use for a new definition or something like that, or a word that we want to emphasize. Okay, I want to just 1 second before we start. Yeah. So by the way, nothing here is something that you're expected to do. This is all just overview. We're going to get started doing it together in a little bit. But I just want to show you some of the overview here. So this is one of the ways that LaTeX works. You write a command to change how the text is supposed to be. Okay. Yeah, question? Sorry, 1 second. Why can I not find the mute button for everybody? Oh, here we go. So 1 second. I'm just going to remember, please only turn on your mic if you have a question or if you're answering a question. I'll be right back. I just want to plug in my computer because my battery's running low. Okay. Okay. So this is kind of one example of how LaTeX works. Okay, what do we have next? So more examples of other kinds of commands. So maybe you want to write a list. So you have tea, milk, and biscuits. You want to put them on a list. Well, LaTeX has an environment called itemize. You can write \begin itemize, and then for each item in your list, you call it an item. So you say \item and you write tea, and then \item and you write milk, and \item and you write biscuits, and then you end your itemize. This itemize here is called an environment. Okay, it means you're not going to be doing regular text anymore. You're now in some environment, and this environment is going to make bullet points over here. Again, you don't need to remember anything yet. This is just some examples of kind of how things work in LaTeX. Another thing, you want to include a picture. So this is a picture of a gerbil and an apple and an umbrella, and it has a name. And you have this picture somewhere on your computer. Well, to include the picture, you write begin figure. Figure is also an environment, kind of like itemize. So begin figure, include graphics, gerbil. That's what you named your picture. And end figure. And then if you have a file that is a picture of a gerbil, that will put that gerbil into your document. And then another thing that you might want to do is mathematics, right? So you might have some mathematics over here that involves some Greek letters. So alpha plus beta plus 1, and you might want to number this equation with a number 1. Well, the way that works is you just write begin equation, and then you type alpha plus beta plus 1, and then you end the equation. And this automatically turns what you write, which is the name of these Greek letters, you're writing alpha and beta, that turns it into what you end up getting as your output is you get alpha, you get the actual Greek letters, alpha plus beta plus 1. And because you put it in an equation environment, LaTeX will automatically number your equations so that you can refer to them with a number. Okay, so these are just some examples of things that LaTeX can do. And the certain, I guess, just kind of principles that will help you be successful when using LaTeX is that we use commands to describe what it is, not how it looks. So our command for, for itemize, we're not worried about how big the spacing is between these rows or whether it's indented or what symbol we use. We just tell it to itemize and then LaTeX will make it look nice. Okay? So we're saying what it is. What is it? It's a list of items. We'll let LaTeX do the work for how it actually looks because LaTeX is going to do a good job. Okay? We focus on what it is that you want to write and you let LaTeX do its jobs. Okay, so you're not going to have to worry about where's the white space in your document and how much space is there between paragraphs and all this stuff. LaTeX will just do all of this for you. Okay, so this is going to be kind of the attitude that we're going to take when trying to write a document in LaTeX. Okay, so getting started. So we are going to write the smallest LaTeX document that can exist. Okay, so there are three things that you need in every single LaTeX document you write. You need to start with a document class. So for us, that document class is always going to be article. There are different document classes that can make things look a little different. So you can have a book document class or a report document class or a letter or something like that. But for us, for just a normal piece of paper with normal math on it, we're going to always use article as our document class. And then your document needs to begin with begin document, and it needs to end with end document. And whatever you write between the begin document and the end document is the thing that's actually going to show up that you're writing. That's what's actually going to show up in your LaTeX. Okay. All right. So a few things to notice from this, and then we're going to write this ourselves. So all of these commands start with a backslash. So anytime we're like telling LaTeX to do something, like saying, oh, document class or begin or end, you always have to put a backslash to start with. And notice that's different from a forward slash. The backslash is the one that starts on the upper left and goes down to the lower right. It's not the same as a normal fraction slash. That's just a regular slash. This is a backslash instead. Okay, so as we saw, every document starts with a document class command. When you want to say what kind of document class is it, you need to put it inside curly braces. The document class is article, so we put it inside curly braces. Now I want to begin something. What do I want to begin? I want to begin the document, so I put that in curly braces. And what do I want to end? I want to end the document, so I put that in curly braces. And then one other thing here is if you write a percent sign, that's for comments. So if you write a percent sign and then anything that you type after that is going to get ignored in the rest of your document. So the percent sign is to just write comments to yourself that won't actually show up when the document is typeset. So what does this do? The idea is that this LaTeX program is going to write hello world. Okay, that's it. And so you have to declare your document class, begin the document, type what you actually want to type, and then end the document. And if you have a percent sign, that just allows you to write extra extra comments that won't show up. So let me show you what this actually looks like. So in Overleaf, when you open a new document, it's going to look like this. So let me actually just do this later. So let me start from the beginning. So, okay, so you're going to get nothing. Okay, see, there's lots of errors and lots of bad stuff here. And that's because I didn't actually type anything yet. So in your overleaf, by the way, I should say, the left-hand side is going to be where you type stuff, and the right-hand side is going to be the PDF that you get. So let me do this example that was just there. I'm going to write document class, and it already gives you suggestions what to write, but I'm just going to say document class article. Then I'm going to write begin document. Okay. And now I'm going to write hello world. And then I can put this extra percentage. Again, this is comments. This is a comment. It will not show up in the PDF when everything is typeset. Okay, commented will not show up. And then I do end document. And so in Overleaf, once you've typed up the LaTeX thing that you want to do, you click on this thing here that says compile or recompile. Okay, so you click, and then look, you get your program, right? Hello world. And of course, I wrote hello world, but I could say anything that I want to write. I can say, welcome to all of our participants today. If I do that, and now if I click on recompile, it's now going to say, welcome to all of our participants today, right? So anything that you type, if you just want to type normal stuff, then it will show up in the PDF as normal stuff. And I should mention this little arrow up here, this is called download PDF. So if you want what you have over here as an actual PDF file, you just click over here with download PDF, and that's going to download it to your computer or your phone or whatever you're using. Okay. So we can welcome to all of our participants today. Sorry.
Yes, no.
Yes, question.
Yeah, so I'm a bit concerned because with all of this that you are doing, can you do these things without internet connection?
So this is what I mentioned
Like
at the
to,
beginning. You can do this all without internet connection, but you need to then set up LaTeX on your computer or on your phone. And that is a more
oh,
complicated process than using Overleaf. So that's something I can walk you through separately, depending, because that's going to be different for every, that's going to be different depending on what computer or phone you're using to set up LaTeX
oh,
if you want to do it without an internet connection. But you can have it on your computer and work on it without an internet connection. But there's lots of different setups for that depending on what machinery you have. So this I'm showing today, this does require internet connection, but it's the simplest way in the sense that it works the same for everybody. So if you want, and all of the commands that we're doing today will work in your setup also. So the question is, so I'm going to show basically how the language works. Overleaf is just one platform that lets you use LaTeX. And as a platform, it requires internet connection. But if you want to use it without internet connection, then if you can download you'll need internet connection at some point to download the program onto your phone or on your computer. But once you've done that, then you can use it without internet connection. Okay.
okay, thank you.
I'm going to just show how the program works, which is going to be the same in all different ways of using it. The only difference is going to be the getting started, which will be different depending on what machinery you have.
Okay, thank you.
Okay, you're welcome. All right. Okay, so here, this is what we have. So you want to just type something, then all that you need is your document class, begin document, end document, and type anything that you want. And if you notice up here, this says, welcome to Overleaf. Just edit your LaTeX on the left, and we'll compile it for you on the right. If you open the share menu, you can have more than one person working on a document at the same time. I think we don't need to worry about that today. And you can learn more stuff about Overleaf here. But if you notice, everything here has percent sign, right? All of these lines start with a percent sign. And when your line starts with a percent sign, that means it's just a comment. That means it's not going to show up over here, right? Just like I have over here. I start with a percent sign. This is a comment. It will not show up in the PDF when everything is typeset. Okay. All right, so this, let me close that. Okay, so let's go back. Okay, so this is our minimal LaTeX document. It just says hello world. That's it. So let's try to figure out how to do a little bit more than just this hello world. Okay, so Overleaf, let me okay, well that I'm gonna just skip this page for now. Okay, so you type your text in between begin document and end document. And mostly, if you're just writing words, you just write them normally, right? You separate them by one or more spaces, and paragraphs are separated by one or more blank lines. Okay, so you don't have to indent your own paragraphs. You just add an extra blank line if you want a new paragraph. So, for instance, if I say, welcome to all our participants, I'm going to get rid of this comment. So, welcome to all of our participants today. I am glad to see you all attending. So if I do this, I have a sentence here. Oopsie. I'm glad to see you all attending. I want to do something where this, sorry, I'm scrolling this. I'm glad to see you all attending. Let me add an extra line. I'm glad to see you all attending. Today we will learn the basics of LaTeX. Again, I just click on recompiling. So here we have that. Now, if I want to start a new paragraph, what I can do over here is I just skip a line, and now I start my next paragraph. I say, first, open, we will open a document in Overleaf. Okay, so if I recompile this, then now what you see is it starts a new paragraph over here, right? It indents over here. Because the LaTeX way of starting a new paragraph in the text, you just skip a line, okay? And one thing that I should notice is that I should also say is that spacing in your typing will not be reflected in the compiled PDF. So notice I put a lot of spaces in between some of these words in the compiled PDF. But then if I compile this all, the LaTeX doesn't do the spacing. It is going to do its own spacing. Okay, it's going to do the right spacing to make everything look nice. So it just ignores how many spaces you put between words, which is fine. So if you put an extra space by accident, it won't actually show up there. It won't do anything. So what you need to know with spacing is you have, if you skip a line, that gives you a new paragraph. And if you just leave extra spaces in between words, nothing happens. Okay? So you have this over here. This ends up just looking like this. And if you want, you can also slide this back and forth. If you want to have your PDF be bigger than your text over here, you can do that. If you want your text to be bigger than your PDF, you can do this. I usually like to keep it somewhat in the middle of the screen to do this. Okay. What do I want? Okay. So this is so mostly you just type your text normally, right? So they're writing the rain in Spain falls mainly on the plain. Remember, we saw that you can, I just want to see you can emphasize a word if we wanted to put some word in italics. So let me write this over here. So spacing in your typing will not be reflected. Let's say I want to emphasize not. So I'm going to write \emph for emphasis, and then always curly braces around what I want. So spacing in your typing will not be reflected in the compiled PDF. Now, when I recompile this, you can see that the not is now italicized. Okay, I emphasized the word. Okay, so LaTeX emphasized it for me. What I had to do is do \emph and then put the words that I want inside curly braces here. And this is nice because anytime you do backslash, it'll automatically turn it blue so that you can kind of see, okay, this is a LaTeX command. This is a LaTeX command. Document class begin, env, and end. Okay. And for the end document, if I want, I can put a bunch more spaces here. It doesn't matter. Nothing's going to change. LaTeX basically doesn't care about how many spaces you put anywhere, except that if you skip a line in between two things that you're writing, it will make a new paragraph. Okay. Okay. So here we have this. Okay. So oh no, wait, that's not what I wanted. Okay. All right, so this is how the spacing works. So we'll get to math soon, but before we get to math, I just want to say a couple of things that are a little bit tricky when you're typing. So the first thing is if you want quotation marks, if you just use quotation marks, then you're going to get something that looks a little weird. So let me show you what that is. So if I just use quotation marks, if I'm going to say like, hello, said the cat. Okay. If I do that with quotation marks, what you notice here is I get these backward looking quotation marks at the beginning, which you don't really want. So one little LaTeX quirk with quotation marks is instead of using the quotation mark sign at the beginning, you have to do two backticks like that. And now if you compile this, you end up getting the correct quotation marks. So quotation marks, an opening quotation mark, you want to use two backticks like this if you're ever typing anything with quotation marks. The other thing that you want to be a little careful of is that there are certain common characters that have special meanings in LaTeX. Okay? One of them we've already seen is the percent sign, right? The percent sign makes everything else a comment, right? So there's other things. So this hash sign has some meaning, and ampersand has some meaning that we don't need to talk about today. The dollar sign has a meaning that we will talk about today, but these are all special things. But what happens if you actually just want one of these signs? What if you want to type a percent sign? Well, you can't just type out a percent sign because that's LaTeX code for a comment. So if you actually want to get a percent sign, what you have to do, they call it escape it, but what you do is you have to put a backslash before it if you want to get it to appear. So let me show you what that looks like in practice. Okay, so if I want to say, so wrong would be this. If I want to say 5% of 100 is 5. The problem here is what happens if I compile this? It just says 5 and nothing else comes out. And that's because I put a percent sign here, right? I put a percent sign here, and the percent sign just made everything else afterward a comment. So none of this shows up in the PDF. So the correct way of doing this is 5. If you actually want a percent sign, you have to type a backslash before the percent. And now you just carry on. 5% of 100 is 5, and you'll see that this will show up exactly the way that you want it to. Okay. So similar thing. So wrong, if I say like another way of writing $5 is $5. Okay, if I just write that, I'm going to compile this and I'm going to get some horrible error. Okay, or in particular, right, this little red thing means that there's an error, and you notice the dollar sign didn't show up at all. Here, there's an error. You can click on it, and it says, oh, look, there's a missing dollar sign there. So something is going on wrong. But the correct way of doing this instead, so I'm going to put the wrong ones in I'm going to comment them out now. I'm going to say the right way of doing this is another way of writing $5 is backslash $5. If you want a dollar sign or a percent sign, you got to put this backslash instead. And now when we compile it, everything is fine, and you get your dollar sign. Okay, so for certain punctuation marks, if you're typing them in just standard typing, you need to put a backslash behind them in order to get them to show up correctly. Okay, and this is all the same whether you're using Overleaf or whether you're using a LaTeX on your computer or phone without an internet connection. Okay. Any questions so far?
No question, Fernanda.
Good. Okay. All right, so let's keep going. Let me erase that. Okay, let's keep going here. So, okay, so these are just some little tips for when you're typing. Okay, so sometimes, yeah, if you write something wrong, sometimes you'll just get an error, right? So, and if you get an error, sometimes you get no output at all. So, for instance, if you misspell emph and you write it meth instead, it's going to stop and it's going to tell you undefined control sequence. And that just means a control sequence just means a command. It's just a way of telling LaTeX something. And if you have an undefined control sequence, it won't print out anything because LaTeX sees this backslash meth and it doesn't understand what you're trying to do. So let me show you what this looks like. Okay, so if you type, if I'm going to type the rain in Spain falls mainly on, well, falls, so I'll do this, meth, mainly on the plane. If I do this and I try to compile, then see, I mean, it tries to do something, but notice it didn't emphasize. And again, I get this red thing here. That means I have an error. I click on this red thing over here. It says undefined control sequence. The compiler is having trouble understanding a command that you've used. Check that the command is spelled correctly, right? So what's wrong? Okay, if you've misspelled it, just try to do something. Okay, so let's see. So now when I fix this, instead of meth, I'm going to write emph for emphasis. And now if I recompile, I have mainly in italics and the error has gone away. Okay, so LaTeX will always give you an error message if you've done something wrong. Okay. Okay. All right. So, but basically, when you have an error, if you get an error message, you want to fix it as soon as you can, because if you get lots of error messages, then it can start doing weird things and it can be hard to regain control of your document. Okay. So you want to fix any error as soon as it shows it to you. Usually it's pretty easy to see that, you misspelled something and it'll tell you where the error is. Okay. So let's type this. So we want to typeset this in LaTeX, right? So in March 2026, Congress raised that ceiling an additional 79.79 trillion to 8.797 trillion, which is approximately 68% of GDP. As of October 4th, 2008, the Emergency Economic Stabilization Act of 2008 raised the current debt ceiling to 11.3 trillion. So let's type this. Remember how to do it. I'm just going to copy it over here. Where are we? Okay, so I'm going to copy it over here. So this is the text, but what do we know? So everything here in March 2006, this is all fine. Congress raised that ceiling, that's fine. Aha, here's a dollar sign. We remember whenever there's a dollar sign, we got to put a backslash before it. Here's another dollar sign. We got to put another backslash before it. Yeah, actually, maybe let me show you what happens if I just do nothing and I try to compile this. I'm going to get, yeah, garbage, right? Total garbage. Some split things, bad spacing, which is approximately 68 October, nothing. This is complete garbage. Okay, and notice I got an error message. Okay, missing dollar sign insert. I did something wrong with the dollar sign. So what I want to do to get it to look correct is I have to remember, okay, I want a dollar sign. I need to do backslash before the dollar sign. I want a dollar sign here. I need to do backslash before the dollar sign. Let me try to, can I zoom in? If I want percentage here, I have to do a backslash before the percentage. And then if I want my quotes to be right, I want to do backticks at the beginning of the quotes. And then here there's another dollar sign. So I want to put a backslash before it. And now if I compile it, no more errors, and now it looks normal, right? In March 2006, Congress raised that ceiling an additional 0.79 trillion to this. whatever it says, this looks correct, right? Raise the current debt ceiling to $11.3 trillion. Okay. So you just have to be careful with some of your punctuation marks. Okay, and if you're doing this on your own, you can actually just open the exercise directly in Overleaf and do it yourself, and then you can click to see the solution. Okay, so we're all mathematicians here, right? So I want to get to actual mathematics. So how do you do math? This is where LaTeX really shines. Okay, so when we do math, one of the ways we do it is by putting math inside dollar signs. Okay.
Before you proceed,
Sorry, Emmanuel.
yeah, I
Yep.
said before you proceed,
Before we proceed, yep.
I'm going along. I have my laptop
Hmm.
open, but what I see free. Then I see charges
No, use the
for.
free model is fine.
Okay, I try to click the free,
Yep.
but it's not opening.
It's not opening. So did you already
Yeah,
gave your email and password?
yeah, I signed in.
Okay,
I
you
have it
signed
yesterday.
in. Yep.
Yeah, I signed in already. Yeah.
Hmm. And so when you click on free model,
Okay, so if you can look on my screen, you
mhm.
get your current plan free, then you
Yep.
have uh, standard, then you have pro.
Yeah, standard should be fine.
Okay,
Yes, you
so
click on
get
standard.
standard, but
Yep.
it's $21 a month. Then you see, okay, I can try for free. Okay,
Yep.
I can try for free instead. Okay,
Okay. Yeah, yeah.
yeah, okay, thank you.
Okay, you're welcome.
Okay. Thank you.
Okay, you're welcome.
Yeah, that's good. Anything I will come to you. Yeah.
Okay, great. Okay. So what do you do for math? So the main thing you need to know about math is anytime you want to write math, you want to write an equation, you want to put it inside dollar signs. That's what's going to make it look like math. So here they say, let a and b be distinct positive integers and let c equals a minus b plus 1. So you can just type that out, but it's not going to look very good. What will look better is anytime you have a math variable or a math equation, we should put it inside two dollar signs. You put a dollar sign at the beginning and a dollar sign at the end. Okay, so use one at the beginning, one at the end. Okay, and LaTeX also doesn't care about your spacing. As we said, if you just write let y equals mx plus b or let y equals mx plus b with lots of spaces, LaTeX doesn't matter. The output is going to look exactly the same either way. So let me show you some examples of this. Okay, so we're going to type some math. Okay, so so I could say solve the following if I'm writing an example question. Solve the following equation for x. And notice I put x in dollar signs because it's a variable. And my equation is going to be 3x plus 7 equals 10. Okay, so what happens when I compile this? See, it says solve the following equation for x. 3x plus 7 equals 10. Okay, and this looks much nicer than if I take out all the dollar signs and just type it normally, it's not going to look as nice. So I'll show you what happens if I just take out all of the dollar signs. Then this doesn't look as nice because the math blends in with the rest of your writing and it's not set aside. But when you put everything in the dollar signs, it makes it look a little bit more like math. Okay, so we solve the following equation for x. 3x plus 7 equals 10. Okay, so we can put this all in dollar signs. And this is the basic ways of how you do an equation. And then I'll say another thing. If you want the equation to be on its own line, use two dollar signs at the beginning and end. For example, let's do the same thing. So for example, solve the following equation for x, And now instead, I'm going to do $2 signs at the beginning and the end. I'm going to write 3x plus 7 equals 10. And now if I compile this, it puts the equation on its own line. So if you want the equation to be on its own line, use $2 signs at the beginning and the end. So because I put a double dollar sign and a double dollar sign, this equation showed up together on its own line. And that can be useful. Okay, it showed up centered and on its own line. Okay, so if you want to type a math equation, you put it in between dollar signs. This is why when you want an actual dollar sign, you have to do backslash dollar sign instead of just writing a dollar sign.
Dr. Obus?
Yes.
Jasper.
Yes, Jasper.
So is there any way that the equation can be aligned from the right instead of it coming like directly in the middle?
Yes. Although
On the left part, I mean, not the right, but the left.
The left, yes, there is a way to do that. Usually what you'd want to do there is, I actually have to look up how to do that because usually it looks better when it's in the middle. Let me just see, LaTeX align equation left. I think you just have to use yeah, it's a little more complicated. Yeah, let me not talk about that now. I can send you how to do that later. It's a little bit more complicated if you don't want the default, which is aligning the equation in the middle.
Okay.
But I can tell you how to do it later. Okay, so use these dollar signs in pairs, right? And that gives you an equation. And then if you want to do other things in math, for instance, in math, we often use a subscript or a superscript over here. So to do a subscript, you have to use an underline, underscore, and to do a superscript, you use a caret. So here they want y equals c2x squared plus c1x plus c0, where the 2, 1, and the 0 here are subscripts, and the 2 is a superscript. Then you use the underscore for the subscripts and the caret for the superscript. So let me write an example of this. So if I could say something like the Pythagorean theorem says that if A, B, and C, putting them in parentheses, on parentheses, are the sides of a right triangle, and C is the hypotenuse, then, and now I'll put the theorem in double dollar signs because it's important. I'll write A squared, so that's A caret 2, plus B squared, B caret 2, equals C squared, C caret 2. So if I compile this, right, it looks very nice. So the Pythagorean theorem says that if A, B, and C are the sides of a right triangle and C is the hypotenuse, then A squared plus B squared equals C squared. So you tell LaTeX what you want it to do, use the caret over here, and then when you compile the PDF, it's just going to look nice. The exponents are going to look the way that they're supposed to. Okay. And for instance, I could also say if we wanted to do, let's say, the quadratic formula says that if we have an equation, and the quadratic formula is going to use some more complicated stuff. So let me not do this example yet. Okay. Let's say, I'll just say, on the other hand, if we instead label the sides, we can label them S1, S2, and S3, right? Those could be the sides of the right triangle. Then instead of A squared plus B squared equals C squared, I get S1 squared plus S sub 2 squared equals S sub 3 squared. Okay. And now if we recompile this, it's going to look nice, right? S sub 1 squared plus S sub 2 squared equals S sub 3 squared. So this is how we get superscripts and subscripts when we're writing math. You can only do this inside math mode. You can't do this. You can't do this when you're just typing text. Everything here has to be between dollar signs or double dollar signs. Okay. When you're within dollar signs or double dollar signs, that's called math mode. Okay. So we're already now starting to see some of the power, right? I mean, this is really making the math look quite nice. Okay. So we've seen how we do subscripts, how we do superscripts, and in general, how we put math in
Well
between
done.
$2 signs. Yes, question.
Yeah, Victor.
Yeah, Victor.
Yeah, so, looking at the Pythagorean theorem, is there any way that you can give the command to bring the diagram like the right angle triangle using the variable values or
Oh,
let's say
so
the
to
vectors?
actually write the geometry, yeah, that there is a package for that, but that's a little bit more complicated. So that you might
Okay.
want to just draw in at the end, or the best thing to do is to make draw the triangle, have that be a separate file, like a PDF or something, and then you can insert it into the document. So LaTeX can do drawing for you, but that would be a full other workshop to do it. So the answer is yes, but it takes a little work. But there are tutorials to teach you how to do it.
Okay.
Okay. Yeah. Uh, Okay. So all right, so let's move along. Okay. Oh, so another thing is if you have subscripts or superscripts that are more than one character, then you have to use curly braces to keep them in a group, right? So I don't like this example. Let me use a different example. So for instance, if I try to write uh, another example, if I say uh, here is a mathematical fact. Well, if I take 2 and I raise it to the 10th power, again, I want to do everything inside $signs because it's math. So 2 to the 10th power equals 1024, right? That's fact. Now, what happens if I compile that? Oh, well, that's not so great, right? Because you have a 1 up here, but only the 1 got into the exponent, and the 0 ended up just back down here. This doesn't look like 2 to the 10th, right? I mean, this looks really bad over here. So what you have to do instead is if what you want in the exponent is more than one character, then you need to put the entire exponent in curly braces. And now when you recompile it, it'll look correct. Now you have your correct exponent up here. So similarly, so I'll say similarly, if you want more than one character in a subscript, you need to use curly braces. Okay, so for instance, you could have A1, let's say you had a bunch of variables that you called A1, A2, dot, 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 and then A9, and then I don't want to just write 10, because if I do that, um, sorry, if I do that, then you see we have the same problem that the 10 doesn't show up completely in the subscript. That 0 is just written regular. So if instead I put it inside curly braces there, now I recompile and it shows up correctly. I get A10. Okay. Okay. So you need to use curly braces for these subscripts. Okay. And then, so other thing, there's just also any Greek letter you want, you can just type the name of that Greek letter with a backslash. So if you want some Greek letters, you could just type alpha, beta, and gamma. So let's actually look at this. I guess this is some chemistry. Oh, this is radioactivity formula. So mu equals A e to the Q over RT. So how do we type that? We do that as an example of Greek letters. So you could take mu, you just do backslash mu equals e to the, so use your caret there, e to the, and then everything that we want in this exponent. So we want q divided by RT. So I'm going to write q divided by RT. You got to put the whole exponent in curly braces, finish with a $sign, and we recompile it, and we get exactly this letter mu over here. And if you don't want mu, if you want a different Greek letter, you want rho, then you can do it and your mu will become a rho. Or if you want alpha, then you recompile it and your rho becomes an alpha. So any Greek letter you want, you just type in its name with a backslash and it will give you that Greek letter. Okay. Okay, I'll send out this file, by the way, to everybody when the workshop is done. Okay. All right. So various different things that you can do. You can also do a summation notation. So you can do a sum from k equals 1 to n. This is this example that they're doing here. So the sum, the subscript is what goes in the bottom of the sum. That's k equals 1 in curly braces. And then the superscript with the caret, that's what goes in the top of the sum. We're saying up to n. So if you wanted to write capital omega, when you want a capital Greek letter, you just write it capitalized, equals the sum from k equals 1 to n of little omega k. Like let's say that was a formula that you wanted, we can type that in. So let's actually just type this example. If I'll put it in its own line. So capital omega, which I can do with just typing the omega capitalized, equals backslash sum. Everything's a command. So anytime you're writing a word that you want LaTeX to interpret, you're always putting a backslash there. So what goes below on the sum is I equals 1. And what goes above in the sum is n. That's the caret of now little omega sub I. I don't need curly braces because my subscript is only one character. I close my double dollar signs and we see what happens. We compile it and we exactly get this. So we get that big omega equals the sum from I equals 1 to n of little omega I, right? So you can put all of these, you got Greek letters, you've got nice summations, it looks really beautiful, you've got subscripts, and you can type this all in a relatively simple formula, right? You just need to know how to do a sum and how to do Greek letters and how to do subscripts and how to do superscripts. And you want to put it in its own line, then you have to put everything inside double dollar signs to do that. Okay. Yes. Okay. This is called Overleaf. Okay. So let's just move on. Okay. So displayed equations, I'm gonna maybe skip this for now. So, do I want to do interlude? I just want to see if I want to talk about environments and equations. Okay. Okay. So we can talk about it. So if you want a numbered equation, oh, sorry, 1 second. I just need to go 1 second. I'll be right back. In the upstairs on the bed, there are some clean clothes that we're packing because we're going away. So just you can, if you need to make the bed, just make the bed and put it back on the bed. Okay. And Sure. Okay. Sorry about that. Okay. So, all right. So if you have a big equation, you can even remember how we had begin document and end document? We had up here at the very beginning of our document, we had begin document, and at the very end of our document, we had end document. Well, you can also have begins and ends for little things. So if you want an equation with a number on it, you can do begin equation and then write an equation and then end the equation, and that will automatically label your equation with a number. So let's do this quadratic form example. I'll show you how this happens. So now I'm going to make an equation. So I do backslash begin equation, And now in Overleaf, it'll automatically just write the end equation for you because it knows that if you begin an equation, you have to end it. But if Overleaf doesn't do it, you can always write that in. So maybe I'll write that in just to show how we can write it, \end equation. And now I'm going to say, so I'll say up here, the roots of a quadratic equation, ax squared plus bx plus c equals 0, right? Again, I put that in dollar signs because it's math, and I use my caret for up here. So the roots of a quadratic equation, ax squared plus bx squared plus c equals 0, are given by, and now I'm going to write the quadratic formula. So x equals, now I should say, when you're in an equation, you don't need to use dollar signs because the equation counts as the dollar signs. So when you're inside begin equation, end equation, it's as if you already have dollar signs there. Everything that you're writing there is in a dollar sign. So now what do we have? Well, we know it's minus b plus or minus square root of b squared minus 4ac over 2a. That's a fraction. How do you do a fraction in LaTeX? Well, you do \frac for a fraction. And then what you do for a fraction is you write the numerator in one set of curly braces and then the denominator in the next set of curly braces. Okay, so I mean, if I just literally compile it like this, it's going to say x equals numerator over denominator, and you notice it gives us a number. This is going to be equation 1. This allows us to number our equations over here. But I don't want to write numerator over denominator. I want to write the actual quadratic formula. So I have to write the formula, and the numerator is minus b and then plus or minus. So there's a special symbol for plus or minus. By the way, here's a symbol cheat sheet. I'm going to send this to you. LaTeX mathematical symbols. It just tells you how to get basically any symbol that you might want. All sorts of arrows, all sorts of sums and products, math formulas, all sorts of designs that you want. All of these have little LaTeX codes. And so you have a cheat sheet here where you can find them. So it turns out that if you want plus or minus, that symbol is given by PM. So again, it's a LaTeX symbol, so you always put a \. So P plus or minus, and now we want square root. You do square root as SQRT. And then inside the square root, we know that we have b squared minus 4ac. And inside the square root, everything goes in curly braces. So that's the numerator. And then the denominator here, we have 2a. So when we compile this now, instead of numerator and denominator, we get the actual quadratic formula. Okay, so you have negative b, the PM gets translated into plus or minus, and then SQRT gets translated into a square root sign that automatically is the correct size to type in b squared minus 4ac underneath the sign. And then because we used our fraction means we put the numerator in the first set of braces and the denominator in the second set of braces. And so when you type this out, this ends up giving you x equals minus b plus or minus square root of b squared minus 4ac over 2a. Okay, so this starts to get very, very nice. And when you're starting to learn it, there's quite a few commands to learn, but if you use it regularly, then it becomes like learning a new language. You basically just get used to it at some point. Okay, so this is what they did over here. So this is exactly this example here in the tutorial. So x equals frac of minus b plus or minus square root b squared minus 4ac, and then the denominator is 2a, and we end the equation. Okay. Okay. Right. So this is one thing also. So if you want to have an equation not only on if it was just on its own line, we could just use double dollar signs. But if we wanted to get a number, then you use begin equation and end equation. So I'm going to write this as a comment. Using begin equation makes sure that the equation will be given a number, which you may or may not want, depending on your context. Okay. Okay, I'll say here, capitalize the name to get a capital Greek letter, right? All of these things are comments, right? If I recompile, nothing's going to change. Remember, because this percentage is a comment. Okay. Okay, so we're getting close to the end. So what is an environment? This slide's not important. I'm going to skip this slide. Okay, so I should say that so this slide is important. So the begin and end commands are used to create many different environments. So this is one that we saw right at the beginning of the tutorial. There was something called itemize. So you can, if you want to make a list of bullet points, then you can use itemize. So let's say in the shopping list is biscuits and tea. That's going to give you biscuits and tea. And if instead of just having bullets, you want them to be numbered, then you can do begin enumerate. And this is for numbers. Okay, so let me show you an example of this. Oh, wait, sorry, that's not what, sorry. Yeah, some example of here, I could say some important areas of mathematics are, and now I'll write begin itemize. I could write item algebra, item geometry, and item calculus. Okay. So when you have, again, you have a begin itemize, backslash begin curly braces itemize. It has to end with an end itemize. This is putting yourself in what's called an itemize environment. And then each item has to be backslash item. That's what's going to tell LaTeX to make it an item. And if I compile this now, I get some important areas of mathematics are, and then with just little bullet points, algebra, geometry, calculus. And I could say, or if I want to number everything, now I do the same thing, but instead of begin itemize, I use enumerate. Begin enumerate, item algebra, item geometry, item calculus. So for begin and end enumerate over here, now if I recompile it like this, now you see instead of getting bullet points, I get 1 algebra, 2 geometry, and 3 calculus. Okay, so we've seen, let's just look at our page. We started from just regular typing, then we got some punctuation marks like quotation marks and percentages and dollar signs. Then we started writing some math equations. Then we displayed a math equation. Then we did equations that have subscripts and superscripts, some more complicated superscripts and subscripts, threw in some Greek letters, threw in some summations, and now did a quadratic formula where we had a square root and we had a fraction bar and everything. And now here we show that we can make a list. Important areas of mathematics are algebra, geometry, calculus, or if I want to number everything, 1 algebra, 2 geometry, 3 calculus. This is using itemize over here or using enumerate over here. Okay, so these generate lists. So one little interlude. So everything that we're using so far is built into LaTeX. There are fancier and fancier commands that come with extra packages. They're like expansion packs for LaTeX. There are libraries of extra commands and environment, and there's a lot of them that are freely available. And if you want to load some of these packages, you have to put one extra little command at the beginning of the document, which is called use package command. Putting it in the preamble, this means before you begin the document. So, for instance, the AMS, that's the American Mathematical Society, AMS Math gives you just more stuff that you can use. So there's kind of no harm at the beginning of your document if you want to just use package AMS Math. You can always just put this line in. So I'm going to go back up to the beginning of the document before begin document, and I'm just going to, oh wait, I'm just going to add this line, use package, always with a backslash, AMS math. That just gives you some extra math symbols that you're allowed to use. Okay, it doesn't change anything. If I recompile this, it's going to look exactly the same. There's no difference. I'm just using an extra package before I begin the document. But now we'll see that when we want to use certain commands from AMS Math, we can use them. So one example with AMS Math is you can use if you want an equation that's not yeah. So what do I want here? Um, Aha, yeah. So I'm going to skip this one, but let's look at this. We have lots of common mathematical operators, for instance, here. So let's say that we want to know, I'm not going to do this exact example, but let's say that we want to take the minimum of a set. Okay, so I could do something bad. I could write it like, so in AMS math, I could write, uh, uh, let's say, what is the min of a set? I could say, like, this is going to be wrong. The min of a set, let's say the minimum of 3, 4, 5, 7, and 9 is equal to 3. Right? So I can write that as an equation. Maybe I'll put display it, just I'll put it in double dollar signs to make it displayed. So, okay. So I could write the min of all of these things is equal to 3, but it's better for min if I put a backslash before it. That is an actual like math function that LaTeX knows. And the minimum of, and now if I recompile this, it's going to look a little bit better. It's going to put the min in Roman instead of as just like a bunch of variables multiplied together. So usually if you want min or max or something like that, then you want to backslash it to make it look better. So this is right, I guess. This is right now. So other math functions that LaTeX knows. Actually, let me do this as an enumerate. I'll do this as an, or I'll do this actually as an itemize. So basically it knows log and trig. So I'm going to begin itemize. And it goes overleaf automatically, gives you an end itemize. So if I want to do, let's say, sine of pi radians equals 0, I do a backslash with sine. That's going to work. So sine of pi equals 0. I could do something like the log, also with backslash, log base 2 of 8 is equal to 3. Put this all in dollar signs. Log base 2 of 8 is equal to 3. Right? And maybe I could do one other one with trig. I could do tangent of 30 degrees. If I want degrees, the command for degrees is actually circ, like for circle. It's a little circle, and I put it as a superscript with a caret to make it a little circle on the top. So tangent of 30 degrees equals 1 divided by square root of 3. Okay. And I can do that. So you can make all sorts of nice things. So it knows all of the trig functions and log and min and max and all of these things. And you want to just do it by doing a backslash before it. That's what it's going to make it look nicely. Because if you don't do the backslashes, then these things don't look so nice. They'll still work, but it looks weird, right? It doesn't, the spacing's not good. They're in italics, which makes them look weird, and there's no space between the function and the number. So you want to, when you're using one of these things as a math function, you always want to put the backslash first, and that's going to make them look much nicer, right? And we're putting this in our itemized list. Okay, so we're just about done. I'm gonna skip this. So do I want to do I think align, maybe I'm gonna save align for next time. Okay, I think we've done enough for one day. We'll do a little bit more of this next time. So maybe I'll save these I'll save these last two slides for the next time, and we'll say a couple more things that we want. Oh, one other thing. If you want to get infinity, it's backslash infinity. So you might think it would be the whole word, but I'm just going to write this. The symbol for infinity is backslash. It's a number, so you got to put it in math mode. Backslash infinity. So I recompile this, you get infinity over here. So that's a kind of important one. Okay, so what have we done? We've typeset some text in LaTeX, used lots of different commands. We've dealt with some errors and used a few different environments, and we loaded packages. We're not going to do part two. Part two is something you do on your own, but we'll spend a little bit more time on part one next time doing some of the things that we've skipped. Okay, so but these are just some examples for how this works for what we have, and I'll certainly send everybody this full document, which is the LaTeX code on one side, which is all just text, and then the output PDF on the other side, which is everything that comes out here. Okay. Um, and there are a couple more things I'm going to say, but they're not going to be part of this tutorial. All right. Any questions so far, or on any of these individual things that we've done here? Okay. So let me reshare my. Okay. So now if everybody can go back to my screen, if everybody can go back to my normal slides, I want to just tell you that there is a quick symbol cheat sheet that can be found, and I realize that the line got cut off a little bit here, but it's just this website which you're not going to remember, but you can look it up on the slide, and it's a cheat sheet for all of the symbols that you might want to find. So let me just see. This is it's exactly over here. It's just symbols.pdf. I'll send this link. I'll send the PDF also to the WhatsApp group. But basically, there's just a whole bunch of symbols that you can use. So here's all your Greek letters, and your lowercase Greek letters, your capital Greek letters. There's a few Hebrew letters that you can use here. There's constructs. So we did this one, right? If you want a fraction like ABC over XYZ, you can write that as frac curly braces ABC, curly braces XYZ. But there's a bunch of other, and square root we also did, \square root, curly braces ABC. If you want an nth root, so like a third root or a fourth root, you put in a little extra n here in square brackets. And then, yeah, if you want to do overlines or underlines or arrows for vectors, anything you want to do, there's all sorts of things that you can do. Okay, so I'm not going to go through this because it's a long sheet with lots of stuff, but there's all sorts of other symbols that you can get just by doing, you want a vertical line, you can do \vert. You want sums and products, \sum, \prod. You want an integral sign, that's \int. Double integral is \int. So these are all things you can look up. These are all the functions that LaTeX knows. So knows arccosine, cosine, cosecant, exponential, all sorts of other stuff, log, limit, determinant, all of this stuff you can get in LaTeX with just backslashes. And then and much more stuff. Okay, millions of extra symbols that you may not have any real reason to use, but somebody uses them at some point. Arrows, other miscellaneous symbols like infinity and for all and nabla. This is in multivariable calculus, something that gets used. Clubs and diamonds and hearts and spades. So just millions of things that they've got that you can use. So this is just a little cheat sheet that I'll send to you. And going back to, and if you go back to my slides, we don't really have time for, okay, so I guess this also we talked about a little bit. So to put an equation on its own line, we enclose it in double dollar signs. To get a fraction, use \frac numerator denominator. If you want to put text in bold, you can do this. You can do, instead of env, you can do text BF, and whatever you have on the inside will get bolded. If you want to skip a line in the middle of your text, you use 2 backslashes in a row. And if you want to center your text, you can use begin center, type whatever you want, and then end center. And there's lots and lots of other stuff, and it's all on the cheat sheet. These are just a few examples of things you can do. Maybe we'll practice them a little bit more next time. And then some examples. Maybe this will be practice, and we'll go over this next time. Okay, so for practice, we're going to go over this next time. So how could we typeset, some important trigonometric identities to know? And we're going to enumerate a list. Sine squared theta plus cosine squared theta equals 1. Cosine squared theta equals 1 plus cosine of 2 theta over 2. And an angle of x degrees equals pi x over 180 radians. So we'll think about, how would you type this up? And we'll go over the answers next time for how we would write that. Okay, so I'll say, so thank you for your attention. Next week is going to be the final session for the program, so we'll spend a little bit more time on LaTeX next week, and then we'll spend some time taking stock of the entire program over the last 5 years and discuss what the next steps will be. All right, so when I send everything out today, I'm going to send out the video and the slides, but I'll also send out the Overleaf documents that we made today, so that you can take a look at them. Okay, so thank you as always for your attention. All right, any last
Thank you for the
questions?
time.
Yeah.
Thanks, Don, for the class.
Okay, you're welcome.
And thank you too for the book.
Oh, sure,
The book is
absolutely.
very rich. Yes.
Thank you, Dr. Robert.
All right, you're welcome.
Only me, I always
Did not
suffer with